My name is Jack, and I represent the team at the Center for Immersification as well as the Center of Digital Enablement at SIT to present our work on AI tutors. If we take a moment to appreciate the sheer speed of innovation in the world of large language models or LLMs, OpenAI's ChatGPT, Google's Gemini, Anthropic's Claude, and a plethora of other LLMs are transforming how we work, create, and learn. What's really striking is how quickly they have become essential learning companions for students. This raises important design questions for LLM-based chatbot interfaces for the future of education. The increasing presence of AI chatbots in education has naturally drawn the attention of the HCI community. Research on conversational agents has demonstrated the usefulness of LLMs and other AI technologies in learning. Some studies have shown promising results with chatbots that incorporate human-like qualities, such as realistic avatars or expressive animations. This trend is mirrored in the industry, with companies like OpenAI moving towards more human-like interfaces in their chatbots. However, other work suggests that learners may benefit from a less human-like, more transactional approach to chatbot interaction. For example, a purely text-based interface can just be as effective, if not more so, in certain contexts. With the increasing use of AI chatbots in education and the fast pace of industry advancements in their chatbot technologies, it is crucial to understand the impact of different avatar representations on the learning experience. As we delve into the world of AI chatbot tutors, it's essential to recognize the wealth of knowledge that exists in the field of pedagogical agent design. For years, researchers have been exploring the impact of visual and auditory elements on learning, recognizing that these design choices require careful consideration. Prior studies highlight the influence of factors such as avatar demographics, emotions, and even instructional roles on learning outcomes. These findings provide a valuable foundation for designing modern AI learning chatbots. However, the advent of LLMs presents new opportunities and challenges. LLM-based chatbots possess distinct conversational capabilities that go beyond those of earlier pedagogical agents. This necessitates a fresh perspective on avatar representation, as these advanced language capabilities may interact with visual and auditory cues in complex ways. This has motivated us to design and implement an LLM-based AI tutor platform that offers 3 different avatar representation modes. First, a regular text-based mode labeled Mr. Empathy, also known as the no avatar condition in the study. Next, a non-human 3D character mode labeled Cody, or the mascot condition referred to in the study. The 3D animated character was created by hand, with speaking animations driven by the generated text. Finally, a video-based real-time deepfake avatar mode labeled Larry.exe that mimics the course lecturer, or the deepfake condition referred to in the study. The lip-sync animation and gestures are similarly driven by the generated text in real time. Across all the modes, students can click on the source links to jump to the location of the referenced content in the course materials. For a detailed walkthrough of the AI Tutor platform, please view the paper's supplementary video figure. For the study, 45 participants signed up initially. However, only 23 participants completed all aspects of the study, possibly due to adherence issues over a full 14-week semester in the host university. After providing informed consent, participants first completed a profiling survey that resulted in the demographics shown here. Within the semester, participants were assigned different AI tutor modes over 3 weeks with counterbalancing to minimize order effects. After interacting with each assigned mode, they completed a post-survey to gather usability and motivational data. In the remaining weeks, participants were allowed to use any mode and were encouraged to provide open-ended feedback through the AI tutor interface. Individual semi-structured interviews were then conducted after the semester concluded. For the qualitative data, we employed a reflexive thematic analysis approach. As the primary coder, I maintained a reflexive journal, grounding my analysis in my positionality. While the analysis was primarily reflective, we maintained a codebook. This served as a structured reference for theme development, which was used for detailed reviews by the second author and facilitated discussions with the team. For qualitative data, or rather quantitative data, we processed both the ranking and survey data using appropriate non-parametric statistical tests to determine significance. Now, let's look at the key findings. The results of our study are primarily anchored in rich qualitative analysis, augmented by quantitative measures, with the 5 eventual themes shown here. In this presentation, we will focus on only the first 3 themes, but we encourage you to read our paper for a comprehensive look at all the findings. When asked to rank the 3 avatar modes based on preferences, there were no statistically significant differences in their rankings. Similarly, across all the usability and motivational constructs measured after use of each mode, there were also no statistically significant differences. This suggests that the different representations did not significantly impact perceived ease of use, usefulness, or motivation. However, it is important to note that further investigation is warranted. Nevertheless, thematic analysis of the qualitative data revealed rich insights into user preferences related to learning habits and activities. In general, task-oriented learners prefer text-based utilitarian interfaces, similar to what you would commonly find in current consumer LLM chatbots. They valued things like efficiency and direct access to information. On the other hand, engagement-oriented learners gravitated towards avatar-based interfaces, specifically the deepfake and mascot modes used in our study. They found these modes to be more personable and appreciated the feeling of interacting with a more human-like presence. The second theme highlights the affordances of avatar design on prompting and perceptions on response quality. The avatar's design significantly shaped how participants approached their interactions. Some thought that the close-to-real deepfake mode encouraged them to write prompts closely related to class content. Conversely, the more playful synthetic Cody character encouraged participants to venture into broader, more tangential topics. This suggests that the avatar's visual representation can influence the perceived boundaries of the interaction. Participants also generally perceived the deepfake to produce higher quality and more reliable responses, although in reality, all the 3 modes were based on the same underlying GPT-4o model and RAG mechanism. This highlights that the perceived quality was not based on actual differences in the AI's capabilities, but rather on the psychological impact of the avatar's design. In this theme, contrary to common concerns about the misuse of deepfakes, we discovered, however, various positive aspects regarding trust and engagement when used in the learning setting of our study. Throughout the semester, as students were constantly interacting with Larry in real life, the deepfake Larry appeared to act as a kind of proxy for the real-life instructor. This familiarity significantly influenced perceived trust and capability. The deepfake Larry was seen as a figure of someone capable and knowledgeable, as that was how they knew Larry in real life. Interestingly, the deepfake was also perceived to provide a continuity of learning environment beyond the classroom. As illustrated in this quote, when YouTube explanations were unclear, a deepfake professor in a familiar style felt more effective. By situating our work in existing literature, our research has provided insights into how design principles from traditional conversational and pedagogical agents translate to LLM-based chatbots in learning. For example, our work extends existing literature on learners' expectations of static pedagogical agents, examining how these expectations shape prompting behavior with LLM-based realistic agents. Through this, we recommend implementing human-like cues into the chatbot interface. Interestingly, at the time of this recording, companies like OpenAI are already incorporating better wit and humor into their chatbots' responses, reflecting the growing recognition of importance of these human-like qualities. In conclusion, we identified 5 key themes and offer 3 recommendations for designing modern AI chatbot tutors, emphasizing the importance of personalization, human-like interaction cues, and enhanced engagement through tool integration. We also acknowledge the limitations of our study, which paved the way for future work. As usual, please read our paper for details.